Oh, well, there it was. That was the review. I was going to say, well, here we are. I hope everybody had a good Halloween. We had an excellent time. They came up with their costumes on their own. We asked them what they wanted to be. They said, trash man, trash can. Like, all right, cool. Because it's very stressful to come up with good ideas for matching costumes for twins, because there's so many good possibilities, but they nailed it. Anyways, I hope all of your Halloweens were equally cute. So what we're going to talk about today is, as I said, we sort of now have finished the basic mechanisms part of the class, and we're now going to turn to the sort of applying those tools to interesting questions. And so what we're going to talk about today and next class is a particular set of interesting questions that I find particularly interesting, and is the thing that I'm sort of most specialized in, and hopefully you guys will think it's cool. The basic idea goes back quite far. So Plato's chariot allegory for how humans make decisions is that the emotions are like these wild horses pulling you in all kinds of crazy directions, and then kind of your rational reasoning is like the charioteer that has to corral the horses and guide them to the right place. And the sort of key idea here is that there's this tension, or not tension, but that you can think of this sort of separate roles and separate modes of functioning for emotion versus reason. And obviously this is very old, but in the last, 20 or 30 years in cognitive psychology, social psychology, and behavioral economics, there's been a lot of attention to this sort of model of decision making. It's typically called the dual process models. And lots of people have worked on this, as we'll spend some of the next slides talking about. Danny Kahneman, who won the Nobel Prize in economics for sort of promoting behavioral economics, is sort of most widely associated with this these days. He's far from the first person that talked about it, but he's a big popularizer. And so, but the basic idea of the dual process model is that there are different ways of making decisions. On the one hand, we have careful deliberation, which is the thing that is sort of typically represented in game theory models. When economists think about game theory, you've got your payoff structure, you're doing this complicated prospective reasoning about, well, let me think, what's payoff maximizing for the other person, what's payoff maximizing for me, let's figure out what exactly I should do. Okay, cool, this is an actual equilibrium, I'll do that. Or whatever. That's in a game theory context, but more broadly, it's just whenever you're making decisions, you're sort of thinking very clearly through it. And this is the standard way that economists think about it. And throughout this talk and next talk, we're going to represent deliberation with Isaac, who 1 hour after he was born was carefully considering the world in which he found himself. But the key idea of the dual process models is that this is not a complete description of decision making. In terms of the charioteer and the horses, this is only the charioteer, and you have to also think about the horses. And this is typically described as intuition, or sort of intuitive ways of making decisions. And we're going to represent, and so whereas deliberation is this very calm, calculated, careful consideration, intuition is more just like a gut response, an automatic, maybe emotional response that's not super keyed into the details of the situation it's confronting. It's just kind of doing the thing that you feel like. And so we're going to represent intuition by Miles, who was not quite as tuned into what was going on. When this happened, I took this picture and I was like, oh man. They were an hour old, right? So I was like, this is going to be so good. This is going to go on every talk that I give for the rest of my life. And it does, anyways, I show this picture a lot. So what we're going to start by doing is, rather than immediately talking about this in the context of cooperation, we're just going to think about sort of decision-making in general. And so this is the stuff that Kahneman and Tversky are most famous for, is sort of some of these problems sort of demonstrating in clear ways how people are not always deliberative, but sometimes rely on intuition, and they particularly focus on situations where your intuition leads you astray. And so this is this combination or like team up between an economist and a psychologist, basically, and they really got the field of behavioral economics going. And as far as I know, it's sort of an amazing thing that Dick Thaler also won a Nobel Prize this year for behavioral economics, because it's basically like, yep, here's another one for behavioral economics. So it's good for behavioral economics. Anyways, that is the point being that prior to the work that these guys and others did, in economics, it really was just like basically everything was built on the assumption that people are totally rational and self-interested. And they basically were showing there really are systematic deviations, and they particularly were focusing on deviations from rationality. So they were still assuming that everyone was self-interested because they were just thinking about individual choice problems, like the things that we'll talk about in the next few slides, showing that in the places where altruism, reciprocity, whatever, don't have a role, because it's just like an individual making a choice. And they showed even in those kind of cases, there were systematic deviations from rationality. So, for example, one of the most widely known versions of this, also widely known, and we have some little homeschool pride here, in that this was made up by Shane Frederick, who's a professor at the School of Management. And so this question: a bat and a ball together cost $1.10 total. The bat cost $1 more than the ball. How much does the ball cost? And if you're like most people, the sort of intuitive answer that immediately pops into your head is 10 cents. But if you think about it a little bit more, you might realize that 10 cents is not actually right. Because if the ball costs 10 cents, then the bat would cost $1 more than the ball, which means that the bat would cost $1.10. And when you added them up together, they would be $1.20, not $1.10. I realize I didn't do that here. I didn't actually write it out, but just to be clear about it. So if you say the problem is like you've got a bat and a ball, in total they cost $1.10, say X is the price of the ball, then we know that the bat is $1 more than the price of the ball. And if those things in total have to be 110, then if you solve that, it says that X is actually 5 cents. And the reason that the 10 cents is salient is because you've got $1.10 there minus $1, and so it just kind of pops into your 10 cents. If it was 10 cents, this condition would be satisfied, like the bat would cost $1 and the ball, whatever, doesn't matter. And Shane actually has funny experiments where he gives this problem to people, and some of the people that say 10 cents really dig in on it, and they're like, no, it's definitely 10 cents. But not most people. I think that, this is one of the problems. Once 10 cents seems appealing, but once it gets explained to you, you're like, oh yeah, right, of course. I just kind of forgot about one or two constraints here. Fine. But a lot of people don't get it right. In some data that my collaborator Gord Pennycook collected, which is fairly representative, say only a third of people get it right, and something like 2/3 of the people get it wrong. And then maybe 5% of the people say some other random thing. Who knows what exactly is going on there. Those are presumably people that deliberated but got it wrong. Or just were saying random things or whatever. But so the point here is the way that, the classical models of rationality and deliberativeness think, everybody should just like, oh, okay, well, this is a math problem. Let me do it and figure it out. But there's this very intuitive, compelling answer that just sort of automatically, effortlessly pops to mind. And so the idea of what this test measures is the extent to which people go with that first response and are just like, yeah, okay, great, 10 cents, versus saying, let me stop and think about it. And there's a lot of evidence that this is a stable individual difference, that as people vary in their willingness to stop and think about it versus just going with their first response. And there's a lot of work showing that this correlates with all kinds of interesting things. For example, both Gord Pennycook and I separately, maybe 5 years ago, had studies that showed that people that are more likely to say 10 cents here, so to go with the intuitive response, are also more likely to believe in God, which we had sort of hypothesized in that there are like a lot of these kind of heuristics, these sort of intuitive responses, things like when you see an intentional action happen, when you see an action in the world, kind of assuming that there's some intentionality behind it, like that's a pretty good general rule of thumb because we're social animals, and so usually there is intentionality, but if you sort of apply that broadly, then you tend to like see the hand of God at work, attribute intentionality to non-intentional agents. Seeing the mind and the body as separate, is another sort of natural kind of intuitive response that fits with a lot of religious traditions, whatever. So that's when Gord has a million papers, basically. A good chunk of his stuff is what are all the things that CRT correlates with. And it's also like superstitions and various other things. And most recently we had a paper together that showed that people that are more likely to say 10 cents on this problem are worse at differentiating between fake news and real news, and more likely to share fake news on social media. Anyway, so the point is this is like a representative example of this kind of different thinking styles. Another one, this is one of the sort of classic Kahneman and Tversky problems, is say, okay, so in a study of 1,000 people were tested. Among the participants, there were 5 engineers and 995 lawyers. Jack is a randomly chosen participant in this study. He's 36 years old, he's not married, he's somewhat introverted, he likes to spend his free time reading science fiction and writing computer programs. Which is more likely, that he's an engineer or a lawyer? So, who thinks it's more likely that he's an engineer? Raise your hand. Okay, who thinks it's more likely that he's a lawyer? Okay. So, the idea is, when it's not presented as part of a class on intuition and deliberation, many people say engineer because, this fits the stereotypes of what an engineer is. But this is called base rate neglect, because the idea is when you say engineer, you're super heavily weighting these not really that indicative attributes, and you're ignoring the fact that there's only a 0.5% chance that he's an engineer because of the sort of overall likelihood. And so that's another example of this where you have some intuitive sense of what an engineer is, and you say, oh yeah, that sounds like an engineer. But if you think more carefully about it, you're like, oh wait, no, yeah. Okay, so there they are again. Right, great. Okay, so now another famous one is the conjunction fallacy, and this is the Linda the bank teller problem. So Linda's 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and participated in anti-nuclear demonstrations. I think that dates this problem a little bit. Not that it's just funny to see what the sort of relevant social issues in the 70s and 80s were different from now, whatever. And so then the question is, which is more popular? That Linda is a bank teller, or that Linda is a bank teller and is active in the feminist movement? And a lot of people will say D, again, because it's oh yeah, well this all seems very consistent with that. But here, the reason that this is absolutely not true. So unlike the in the base rate neglect one, there's some version of this where Jack as an engineer could be correct. If this was so specific, basically said Jack works at an engineering firm as an engineer, then it would be reasonable to say Jack is an engineer, despite the fact that only 5 of them are engineers, right? But in this one, absolutely no matter what, it's 100% basically more probable that Linda is a bank teller than that Linda is a bank teller and is active in the feminist movement, because this is a strict subset of that. That is all, there's, yeah, you see what I mean? Strict, right. So it is of all bank tellers, some of them are active in the feminist movement, some of them aren't, and so it's strictly more likely that you could be part of the bigger set than the smaller set. But again, a lot of people will say this, and it makes sense in some kind of intuitive way, just not if you think carefully about it. And so the general idea here that this is supposed to illustrate as I said, is that they have these two different modes of reasoning. There's sort of the more intuitive and more deliberative. But then if you think about, well, why would you have intuitive responses? Like, it seems like deliberation is a great idea and will get you to the right answer. So like, are these intuitive responses just dumb, and is this some like vestige of being monkeys or whatever? And the answer, in my opinion, and I think basically in everybody's opinion that studies this stuff seriously, is like, no, there is a good reason to have intuitive sort of automatic responses. And this is based on this idea of heuristics. So heuristics or a heuristic is a cognitive shortcut that typically works well. It's like a rule of thumb. And so following these rules of thumb can make you look dumb in atypical situations, like the lab. That basically these Kahneman and Tversky problems were designed to take something people tend to do that usually is helpful for figuring things out and put it in a situation where that is going to take you to the wrong answer and make you look dumb, as a way to expose the fact that people are using these rules of thumb. But in general, they work well. This is actually an important basic point about experimental behavioral science, which is that it's often very useful to take people and put them in really artificial situations, even though the way they behave in that situation is not necessarily representative of how they would behave in the world, because it's some weird situation. But by putting them in the weird situation, you can tell how much of their behavior is because they're responding specifically to the situation that you're putting in them, and how much of their behavior is this more sort of generalized spillover from typical contexts. And the thing is, if you just bring them into the lab and you have them do something like normal life and they behave in a way that makes sense, you don't know if that's because they're just figuring out what makes sense there, or they're using some kind of heuristic cognitive shortcut, whatever. So to the extent you want to understand whether people are making decisions by thinking specifically versus using this sort of more generalized response, you have to put them in atypical situations. So I'm going to give you an example of some of the different heuristics that have gotten a lot of attention. So one example is the anchoring and adjustment heuristic. So the idea here is when you're asked a question that you don't really know the answer to, you will typically have some anchor. That is, you'll start with some answer that seems reasonable, and then you'll adjust away from that, and you'll think, does that make sense? Well, it's probably more or less than that, whatever. And not a bad way of trying to figure things out. You take your best guess, and then you reflect on it and see where to go from there. But it allows you to be manipulated. For example, and there's experiments that if you say, what percentage of the United Nations countries are in Africa, and then the participants are shown a roulette wheel that stopped either on 10 lower values, they just stopped at 10 or at 65. And so the idea here is that the experimenter is providing you with an arbitrary anchor. And because most of the participants in these subjects didn't really have any idea what the correct answer was, if you sort of give an arbitrary anchor to people, then people will start with that anchor and adjust away from it. And so if you see a roulette wheel that stopped at 10, then you guess a much lower fraction of UN countries being African than if you see a roulette wheel that stopped at 65. And this is obviously this only works in situations where you don't know the answer clearly, but this is a powerful technique that can be applied in all different kinds of domains, and is certainly a big part of advertising and things like that, of trying to take advantage of the fact that people use this kind of anchoring and adjustment heuristic. Another one is the availability heuristic. So the idea here is that things that sort of pop more immediately to mind that are more available are more salient. So the example, if you ask the question, if a randomly word is taken from an English text, is it more likely that the word starts with K, or that K is the third letter? And people will tend to answer, it's more likely that the word starts with K, because you can immediately think of a whole bunch of words that start with K, and you can't immediately summon up a list of words, the third letter of which is K, because you don't have that sort of as a stored thing in your mind. But it turns out that's totally wrong. Okay, so these are the sort of things that have been the focus of the dual process literature and behavioral econ. It's the stuff that Kahneman's Thinking Fast and Slow book is about. And I don't know if you guys, this is starting to get long enough ago that this was not on your consciousness when it happened, but when this book came out, it was like a bestseller. I remember in my family, it was like the modal holiday gift. So like everybody got it for everybody else. And I don't think anybody actually read it. But everybody at least was buying it and talking about it. And so in this book, Kahneman offers this breakdown of intuition versus deliberation, which are sometimes called system 1 versus system 2, with the numbering being, I think, the idea that the intuitive response happens first, so it's system 1, and then the deliberative response is like a second sort of reaction to it, so it's 2, but it's a confusing nomenclature, so I won't use it. But basically what he says is there's lots of different dimensions upon which decision making varies, and they all, like, this dual process theory kind of collapses all of these different dimensions down onto this intuitive versus deliberative. So you might say the intuitive responses tend to be fast, whereas deliberative responses tend to be slow. Intuitive responses can happen in parallel, like because it's a low-level sort of intuitive gut response, you can get it can be sensitive, it can sort of pick up on lots of different things at once, whereas deliberation is you think about the problem step by step through it. Intuition is automatic, which is to say it just kind of pops immediately into being, whereas deliberation is controlled, that is, it requires cognitive control to make it happen. So sort of correspondingly, intuition tends to be effortless, whereas deliberation requires the exertion of sort of cognitive effort to make it happen. Intuition tends to be associative and sort of drawing like just kind of random like statistical these things happen together, and so that what is basically kind of form intuitive associations between things just from sort of without explicitly thinking about it. If two things happen a lot together, then you sort of make this associative link between them. Whereas deliberation is more like you have a set of rules and you apply those rules to figure out what's going on. Intuitive systems tend to be slow learning because they are generated through these kind of associative processes that in order to get an intuition for something, you have to do it a lot, and then you can develop like a habit for it. Whereas deliberation is very flexible and can immediately respond to the situation it's facing. So an example for this dimension, which I think is one of the most important ones and the one that we're going to focus on, or one of the ones we're going to focus on. So just an illustrative example is when I was a postdoc, I cat sat for my friend's cat, and I never had really had a cat before, and so every day I would come home and I would like open the door, and the cat would try and run out of the door, and I would be like, and I jump, put my foot in the way so that the cat wouldn't run out. And then after 3 or 4 days of that, I just got in the habit, and I would just immediately go and put my foot there when I went to open the door. And then after 2 weeks or something, we gave the cat back because my friends came back from traveling. And then I went to open the door, and I immediately put my foot there, and I had to stop and be like, oh, no, wait, the cat does not exist anymore. And then I had to retrain that automatic in the relevant sense. So anyways, that is the that's sort of the idea there. And then also intuitive responses tend to be sort of more emotional, whereas deliberative responses are not emotionally charged. And so the question then is how do you take this million different, all of these things have something to do with each other, and all of these things have something to do with each other. But if the stuff that we focus on in this class is trying to make these sort of formal game theoretic type models to think about this, we have to try and say, how are we going to break this down into something formalizable? And so what I have done is to say, let's pick some of these dimensions. We can't do the whole thing, but let's focus on the fact that intuition is relatively effortless, whereas deliberation is relatively effortful. And so that's a sort of situation where on this dimension, deliberation is like worse than intuition because it's more costly. And contrast that with this dimension where intuition is slow learning, whereas deliberation is flexible. And so this is a dimension where sort of deliberation is better than intuition. And so what that means is that you can think about these dual process models, or what these dual process models imply about psychology, is saying that there's an ease-flexibility trade-off in decision making, where the intuitive responses are easy but inflexible and insensitive, whereas the deliberative responses are costly. You have to exert effort, time, and so on. But what you get in exchange for that investment is flexibility to be able to respond to the details of the situation that you're facing. And so what we can do now is we can take this sort of definition of intuition versus deliberation and put it into a model or various different models and see what happens. And so the first question that we're going to talk about is just essentially why is it that we have this intuitive mindset? Why aren't people just always carefully thinking about things? Sort of seems maybe like that is a better way of being. And so to answer that question, imagine the following simple model. So let's say that the environment, and I mean environment broadly construed, I'm saying sort of the context in which you are making your decisions, can have one of two possible states. It can either be like A or B, and at any given time, it's in one of those two states, and it varies. And specifically, you can say that each time period with probability P, the state switches to the opposite. So it's A now. With probability P, it'll be A tomorrow. With probability 1 minus P, with probability P, it will be, so if it's A now, with probability 1 minus P, it will still be A next time. And with probability P, it will switch to being B next time. And so on. And so in every time period, the state of the environment is changing. And then you've got agents, and the agents are sitting in the environment, and they can choose one of two behaviors. They can either do capital A or capital B. And the key idea here is that different environments call for different behaviors. So if you choose behavior A, then you get a payoff of 1 if the environment is in state A, and a payoff of 0 if the environment is state B. And reciprocally, if you choose B, then you get a payoff of 1 if the environment is in B, and 0 if A. So basically, you want to choose A when the environment is A, and B when the environment is B. So there's all different kinds of situations that you can imagine of this flavor, where it's just like there's not one optimal behavior, but the way to act depends on the state of the world, and so it's important for decision making to be figuring out what the state of the world is that you're facing. It could be that it's like a feast or famine kind of situation, that it's the state of the world that either food is plentiful or food is not plentiful. And so when food is plentiful, then it's good to just eat a lot. Or when food is not plentiful, then it's important to sort of ration your eating and plan for the future. And so, it's like if you find yourself here, it would be like plentiful, not plentiful, in the two states. Just stuff yourself or think carefully about the future, and and save food, and so then it translates into optimal payoff is when you choose the behavior that matches the state of the environment. So if that was the whole thing, it would be pretty clear that the optimal strategy would be just in every time period choose the behavior that matches the state. But we imagine now we're going to sort of put this ease flexibility trade-off framework into this decision-making context. And so if the idea is that intuition is effortless, but in exchange for that lack of effort, it's inflexible or slow learning, then what it means is that if when you respond using your intuition, you can't just directly assess the current state. The best that you can do is say, well, I'll just do whatever did last time. It's sort of just like a conditioning, like a sort of simple conditioned response, or to say, whatever worked last time, okay, I'll do that this time. And so if the environment is changing with probability p and staying the same with probability 1 minus p, then that means that doing the behavior that was optimal yesterday will be optimal today with probability 1 minus p, because that's the likelihood that the state of the world hasn't changed. And with probability t, the world has changed, and therefore what you did doing the thing that was good last time brings you 0 payoff. So that means the expected payoff for intuition is going to be 1 minus p. And now we contrast this effortless but slow learning process with deliberation. And remember, it's costly, but in exchange it's flexible. And so if you use the deliberation strategy, that means you have to pay some cost c in order to do the stopping and thinking and figuring out what the context is, but you get it correct. And so that means that you're always right, so you always get a payoff of 1 from this sort of strategy, but you have to pay the cost c in order to get that payoff. And so before I analyze it, I'm just going to talk a little bit about what that cost is, because the cost is, what is this? The cost is really the key idea here. And so there's various different reasons that deliberation is going to be more costly. So first of all, it takes more time. And so that can be costly in an opportunity cost sense, which is if you're spending time figuring out what the state is, then that's time that you're not spending doing other things. And also it could be that in some situations you just have to choose the behavior. If you don't choose a behavior within a certain amount of time, then you miss the opportunity to act. And so therefore having to spend more time coming to a decision imposes some kind of cost. Deliberation also uses more cognitive resources. That is, if you're focusing on this task, then you can't be focusing on other tasks. And that's because it requires doing more complex computations to figure out what's going on. Sometimes it also requires cognitive effort to inhibit automatic responses. So when you have this sort of intuitive automatic desire to do something, or like impulse that comes to mind, you have to exert cognitive control to be like, no, don't do that thing, think about it, figure out what you really want to do. Don't eat that piece of chocolate cake, and so on. And these things prevent you from devoting cognitive resources to other tasks. And forget that non-cooperation related bit. And then you could also imagine that the magnitude of these costs varies from decision to decision, how much time you have, what other tasks you have to complete, and so on. And so for now, we're just going to ignore that varying across context bit, and we're just going to say, okay, let's just think about the average cost. So because of the time and effort and so on that is required, when you use the deliberative response, you have to pay some cost c. And so this means now that the expected payoff, this is just repeating, the expected payoff of intuition is 1 minus p, which is the probability that the state hasn't changed, and so just doing what worked yesterday will work again. And the payoff of deliberation is 1 minus c, which is getting it right every time, but having to pay some cost. And so if that's the whole thing, it's pretty straightforward to say what should selection favor, and it's just a question of which is better, c or p. And as long as c is less than p, then deliberation wins. If c is greater than p, then intuition wins. And there's a sort of clear interpretation of this, which is p is the measure of how volatile the environment is, how unpredictable the environment is, right? It's a measure of how quickly things are changing. And so whether intuition versus deliberation is going to be better, like which one is going to be better, depends on how volatile the environment is and how costly deliberating is. And as long as it's less costly, as long as the costliness is lower than the volatility, then it's worth doing it. So that is just a super, super simple formalization of it. But there's another dimension that is potentially important, which is this is sort of ignoring any interaction between the two types of agents. It's just each person is making these individual choice problems and deciding whether to stuff themselves or to space out their food or plan for the future and whatever. But now we could also incorporate the consequences of some not direct interaction necessarily between them. It could be direct interaction, or it could be some indirect influence. And the idea being that if you are acting deliberatively, having other agents around that are being intuitive can potentially screw up your calculations or impose some cost on you one way or the other. So for example, it could be that while you are doing your calculation of is this a time of plenty or not, and you say, look, food is bountiful, no problem. This is in this period. I can just go ahead and eat as much as I want. But if all these other intuitive agents are going crazy, eating all of the trees, then suddenly it might wind up not being as plentiful as you thought, or vice versa, probably even worse, in a time where food is relatively scarce, and so you say, okay, I should do my careful planning and figure out, how much I should eat now, how much I should save for later. If there's lots of intuitive agents running around just eating everything that they can see, that's going to mess up your calculation and cause you to not consume the right amount. So that's one way that basically the calculations of the deliberative agents can be messed up by the presence of intuitive agents. And another possibility is from the opportunity cost, like if there's a resource, like there's some piece of food and two agents come upon it at the same time, and the controlled agent or the deliberative agent starts saying, should I eat this now or should I save it for later? And what really is the right thing to do? And the automatic agent is just nope, and grabs it and eats it, while the deliberative agent is sitting around thinking. That is bad for the deliberative agent. So we can model this by just adding a term where we say that for deliberation, when you make a good decision, you have to pay some cost of thinking, and then also there's some additional cost imposed by the presence of intuitive agents. So if we say the fraction x of the agents in the population are deliberative, then fraction 1 minus x are intuitive, and so w is just some parameter that parameterizes how much intuitive agents being around messes up things for deliberative agents. So if you have w equals 0, this term just goes away and you're back to what you have up here, and so the bigger w is, the more problematic for deliberative agents it is to have intuitive agents around. And now, if you say that the payoff for intuition is just still 1 minus p, and now the payoff for deliberation is this quantity, then you can say, okay, now we're sort of back in a more game theory type situation where and what I mean by that is this is a game in the technical sense that we said from the beginning, like in lecture 2 or whatever, which is through individual choice problems like this, your payoff doesn't depend on what anyone else is doing. You're just doing your own thing. But now the payoff of being a deliberator depends on the likelihood that other people are deliberating versus not. And so now we're back in the world of games where your payoff depends on the choices of others. And it's a little bit more complicated than just the payoff games that we've done before, and that here what matters is not the strategy it's not that you're matched up with one other person, and what matters is the payoff, is the choice of the other person, but it's the thing that matters now is the fraction of other agents in the population that are using one strategy versus the other, but the same basic logic is the same, where you can solve for so we've got this system where we've got some intuitive agents, some deliberative agents, fraction x are deliberative, and then we can do in the same way we've done before of saying, what do the dynamics of this system look like? And in particular, we can ask, is there ever coexistence? Is there some stable fixed point where you have both intuitive and deliberative agents present? And as you may recall, the way that we do that is we set the expected payoff of being intuitive equal to the expected payoff of being deliberative. And at that point, both types get the same payoff. And doing that yields some intermediate value, like x is p minus c minus w over w. And at that value of population mix, you get stable coexistence between the two types. And you can see from this condition what determines the amount of deliberation versus intuition in equilibrium
So the more volatile the environment is, the bigger P is, the better it is to be deliberative. And so the higher the value of X, the higher the amount of deliberation in equilibrium. And then in the inverse, both C and W are sort of bad for deliberation. And so the higher C is, the smaller X is. And then W is a little bit more complicated because it's in both the numerator and the denominator. And sort of affects the interaction between the two. But the point is, this can offer a potential explanation for why we observe in the world the fact that not everybody is equally deliberative. The point is, how deliberative you are, how successful being deliberative is, depends on what everybody else is doing. And so you can get this kind of coexistence where it's not optimal to be one way or the other, but you get some kind of mix. And in the same way that we talked about stuff, it basically becomes like an anti-coordination game, essentially, where if everybody else is being deliberative, then it's advantageous to be intuitive. But if everyone else is being intuitive, then it's good to be deliberative. And it comes out in the same sort of structure. So that is like a first cut at how we can start thinking about this intuition deliberation element of psychology using this kind of game theoretic formalism. And now what I want to do and what we're going to spend most of the next class talking about is what happens if we take it out of this sort of just general decision-making context and we think about it specifically in the context of cooperation. And so when you think about the question of cooperation from this dual process perspective, the question is basically, when people cooperate, is it because they sort of rely on deliberation to rein in these sort of greedy impulses? You have this base desire to, just look out for yourself, and you have to use cognitive control to say, oh no, let me do the right thing and be moral about it here. Or is it the case that there's some intuitive predisposition towards cooperating and helping other people, and then when you stop and think about it, the sort of calculus of self-interest makes you say, maybe actually I should not be helping this person because let me help myself. In which case, it's sort of the intuitive response that is sort of promoting cooperation. And so what we're going to do is we're going to look at a model that uses this ease, flexibility, trade-off conceptualization of intuition versus deliberation to provide an answer to what this question should be. And then we're going to talk about some actual experiments that provide data and test that prediction. And just in the last couple of minutes here, I'm going to say the key to this model is whereas the previous thing we were talking about in the last few slides, what was varying and what it was important to deliberate to be conscious of was the sort of environment in which you were in, and so you figure the environment sort of changes over time, and so it's important to be able to change yourself. But here the idea is going to be that you have different kinds of social interactions. Sometimes you're doing social dilemmas, just prisoner's dilemma kind of things, where there's no payoff maximizing reason to cooperate, and it's just strictly dominant to defect. And so I'm going to call this pure cooperation. Whereas other times, you're involved in games where the various mechanisms that we've talked about, like in particular maybe the reciprocity type mechanisms or signaling is going on, such that it has the social dilemma of the pure cooperation is transformed into a coordination game. And so here, it can actually be payoff maximizing to cooperate. The other person is also cooperative, and so this is like a strategic cooperation. And so what we're going to imagine is trial by trial, there's this variation between whether you are in a coordination game situation where it's going to be advantageous to cooperate, or a social dilemma where it's going to be advantageous to defect. And so this is now going to be the analog of the state of the environment, rather than, is this a time of feast or famine? The question is this an interaction where there are future consequences, so I should be cooperating? Or is this a situation where there's no future consequences, so I can get away with being selfish? So that's where we'll pick up next time.